Good evening to all. So today we will discuss parametric and non-parametric test. So can you hear me? Am I audible?
Yes, sir.
Okay, okay. Thank you. Okay, thank you. Okay. So as we know, so there are two main research approaches. One is quantitative research, quantitative research, and another qualitative research. Okay. So what is the difference between quantitative and qualitative research? In a qualitative research, we explore the new ideas, and we can conduct qualitative research by using narrative research, phenomenological research, ethnography, grounded theory, case study, and many other also. But in a quantitative research, our purpose to testing or verifying the theory, testing and verifying theory. Okay, testing and verifying theory. And we should keep in mind all the statistical tools and technique we use in quantitative research. We do not use any statistical tools and technique in qualitative research. So this is a big difference. Okay, qualitative research can be uh, conducted through or can be analyzed by using a univariate analysis. We can analyze our data through univariate techniques. Second, bivariate technique, and third, multivariate technique. Okay, univariate means we are analyzing only single variable. Bivariate means we are analyzing two variables and finding the relationship between the two. And multivariate technique means we are analyzing more than two variables at a time. Now, in the quantitative research, I told you we test the theory or verify the theory. So we can develop. So there are three methods to conduct the quantitative research. One, we borrowed the tested scale, tested scale, tested scale. This scale nothing but set of questions. It is developed by others and we are using in our study. Second is sometimes it is not necessary the scale which is developed in the developed country. It is not necessary it is appropriate for our country, so we can modify it. We can modify the scale. Okay, so we can add some attributes or we can delete. And third is we can develop our new scale, but it is very long process. First of all, we go for qualitative research and then we will test the hypothesis. Okay, so basically there are three. Mr. Devendra, you have question, query? Should I unmute you? Mr. Devendra, do you have any question? So please write in the chat box. So we use either the tested scale, modified scale, or new scale. We can develop new scale. Okay, now in a parametric test, I told you we have large number of statistical tools and techniques such as one sample t-test, independent t-test, paired t-test, analysis of variance. Okay, repeated measures ANOVA, ANCOVA, factorial ANOVA, MANOVA, MANCOVA, factorial MANOVA, repeated measures ANOVA, and then some non-parametric tests such as Mann-Whitney U test, Kruskal-Wallis test, Friedman ANOVA, Wilcoxon rank sign test, chi-square test, and some multivariate techniques such as multiple regression analysis, discriminant analysis, logistic regression, cluster analysis, factor analysis, conjoint analysis, multidimensional correspondence scaling, moderation, mediation, structural equation modeling, and many other tests. So all the statistical tools and technique we use in only quantitative research. Now, the every statistical tool and technique has its own assumptions. So the which and technique we use, it is depend on the type of data. And there are two types of data. One is metric data and the other is non-metric data. Non-metric data. Metric means our question either in interval scale or ratio scale. And second, the non-metric means nominal scale questions, mutually exclusive, like male, female, rural, urban, nominal, and the ordinal scale. Okay. So metric data, also known as continuous data, and the non-metric known as categorical data. In most of the research paper, you will find other two terms: metric data, non-metric, or continuous data or categorical data. If I am saying continuous data, it means I'm talking about either interval scale question or ratio type question. Okay. So I told you before analyzing, because which particular statistical tool and technique we use, it is depend on the type of data. For example, I am taking very simple example. In case of the example of bivariate technique. Bivariate. In a bivariate technique, you can see it's a simple the metrics. So in a vertical, IV independent variable, DV dependent variable. So there may be two possibilities. Bivariate means there are two variable, Y and X. So there may be four situations. One is dependent variable may be metric. This may be metric, and other is dependent variable non-metric. Your question non-metric. Same as independent variable metric and independent variable non-metric. If you're in case one, there are four cases. You can see four cells. If both the data in a dependent and independent variable in metric form, then you can apply simple regression analysis. So what is the condition of simple regression analysis? Both the questions should be either interval scale or ratio scale, then you can apply. The other case is if both the questions in non-metric, okay, then what happens? Non-metric means the categorical question, like male, female, and the other category. For example, I want to know the coffee consumption among the or between the male and female. So I can divide independent variable into two category, male and female, and do you like coffee, and someone say yes and someone say no. Okay. So when both the variables in the form of categorical or nominal, then we use chi-square test. Okay, chi-square test. If my one variable, that is the one variable dependent variable categorical, there may be other situation. The dependent variable, your dependent variable, yes, your dependent variable Y in a metric data and X is non-metric question. Non-metric means the categorical, like male and female. I want to compare, is it any significant difference between male and female teacher salary in private sector? So I can compare the two categories, which is mutually exclusive. So it is hypothesis testing, or this situation known as independent t-test. So we will use here independent t-test, or if we compare more than two categories, then we will use analysis of variance. Okay, so it's a small example. So there is a one book, I think you have the soft copy of Andy Field book. So on the basis of a variable, you can decide which particular statistical tool and technique we should use in our research paper or thesis. So there is a one path diagram given in this book. At the end of the book, you will find the one uh, the the diagram, so where you can find it. So same as there are multivariate technique, so we will decide whether one dependent variable or two dependent variable. If one dependent variable metric, other non-metric, then which particular statistical tool we use. So it is depend, there are many permutation and combination. For example, the condition of ANOVA, I am taking very simple example. The ANOVA, means y and x. This is metric and this one non-metric. Non-metric means there are three categories. One is control group. Okay, the doctor is giving no dose to the patient. It's a control group. And the other people he is giving 2.5 ml dose. And the third group he is giving 5 ml dose. Okay, so we can use here ANOVA because we are comparing more than two means. So what is ANCOVA? ANCOVA means y equal to x1, that is non-metric question, plus the other x2, it is metric question and dependent variable also. So this equation for ANCOVA, analysis of covariance. So you can go through this book, you will find which particular, how to create our variables, what type of variables we should prepare. Okay, on the basis of these, you can apply the particular statistical tool and technique. Now, I come to the point, that is the parametric test. I told you every statistical tool and technique. So if we are collecting categorical data and you say, sir, I want to apply multiple regression analysis, so we cannot use multiple regression analysis because the assumptions of multiple regression analysis, all the variables should be metric form. If you want to apply discriminant analysis, the condition is dependent variable should be categorical, non-metric, and independent variable should be metric. Same as logistic regression, the outcome variable may be probabilistic in nature and independent variable should be the all independent variable metric. Okay, so which particular statistical tool and technique we use, it is depend on the objectives. Okay, our research objective and the type of data. Now today we are discussing the parametric test. So I told you parametric test assumes the parametric test assumes we use there are some assumptions of parametric test, like the first assumption of parametric test, that is data should be normally distributed, and second is data should be homogeneous, and third data should be collected either ordinal and continuous data, and the data should be independent is score. So the assumption third and fourth in our hand, we can create continuous data, and independent score means one respondent score different from the other. We should not copy the respondents answers. Okay, now the normality and homogeneity, it is not our hand. Now first of all, we understand the concept of what is normality and what is homogeneity, and how to check the normality and homogeneity of our data. Basically, we check the normality and homogeneity of metric data. For categorical data, we do not check normality, we cannot identify. If we prepared our question in interval and ratio scale, then we can check the normality of the data. So there are three ways we can estimate the normality. One is through graphical display, means just see the picture, we can say my data normal or not. Second is value of skewness and kurtosis, and third is KS and Shapiro test. KS means Kolmogorov-Smirnov test. Okay, so there are three methods to checking the normality of the data, and for homogeneity of the data we use Levin test. Now first of all, we understand what is normality. Basically, what is normality? Normality means if through graph we can understand the normality means this is the you can say the histogram, the x-axis and y-axis, x-axis and y-axis. If distribution of your data in a bell shape, the histogram in a bell shape, then you can say the data, it's a bell shape. Bell means ghanti. So it's a normal data, normal. Okay. So data normal, but there may be two possibilities. So how did this diagram come? For example, you are your questions in a 5-point Likert scale, or you are y, and or you are taking the uh, the 1 to, okay, maybe around 1 to 5, 1 to 5 scale. 1 means strongly disagree, disagree, disagree. 2 means disagree. 3 means neutral. 4 means agree, and 5 means strongly agree. Sometimes what happens when it's y, it's a frequency, it's a frequency. For example, my sample size 100, okay, and there is one statement. What is the statement? Generally, we want to know the perception of respondent through statements. I like, I like, I like new education policy. So it's a simple statement. You may agree or you may disagree. It's your personal choice, and sample size 100. For example, if it's a frequency 10, 20, 30, 40, okay, and 50. For example, 50 people are saying they are not, they are strongly disagree with this statement. So it's a, yes, 45 people, and 40 people are saying they are disagree, and rest of the 15 people are slightly agree. So what would be the shape of the curve? Curve would be look like this. When distribution of data in a lower side, then this type of graph is known as positive, positive, positive skewness, positive skew, positive skewness. Okay. If maximum people are giving their opinion in a right side, means they are agree, then what would be the graph? Graph may be this side. Okay, so your data, it's a negative, negative skewness, negative skewness. So for parametric test, it is not desirable positive skewness, it is not desirable, only desirable the distribution of data look like this. Okay, so through graph we can assess the normality of the data. There are two ways. One is through histogram. We can check. I told you, if the shape of the curve normal, okay, look like this, then you can say your data normally distributed, your data normally distributed. Second method, probability plot, pp plot, or qq means quantile plot. So you just see the picture of the data, you can identify whether your data normally distributed or not. So here through histogram you can see whether your data normally distributed or not, the picture 1, picture 2, and picture 3. So here the you can see the data normally distributed, because when we superimpose normal curve on this histogram, it is in bell shape. But in the second, the you can say concentration of data in lower side, so data not normally distributed, so data not normally distributed. Okay, this data not normally distributed, and the skewness, this data desirable for us, this diagram not desirable for us, and this third diagram also not desirable for parametric test, because it is skewed, positive skewed. If concentration of data in left hand side lower tail, then positive skewness. If concentration of the data in right hand side, it is negative, negative skewness. Okay, the second method, that is the pp plot. Pp means probability plot. If all the observation lie in this principal diagonal. Okay, then you can say your data normally distributed. If data deviate from this principal diagonal, this axis, you can say our data is taking shape of curve, so it is not desirable for us, it is not normal. Now you can say the some data above the line and some below the main line, so this data also not normal. And the pp plot means quantile plot again. So through just see the picture of graph, you can say yes, this data is normally distributed, only slightly very few cases above the line and few cases below the line, but my data more or less normally distributed. But you can see second picture here, it is not normal, because it is completely curve, it is not a straight line, not lying on this principal diagonal. So image, you can see this is not normal because it is the curve. So this is the first method to just see the picture of graphs. We can identify whether my data normally distributed or not. Second method ki how to find the whether my data normally distributed or not, the value of skewness and kurtosis. So skewness, I told you there may be the positive skewness and there may be negative skewness. Same as kurtosis, there are three types of kurtosis. Kurtosis tell us about the flatness of the data. So when sample size is less, then the distribution of curve would be look like this. It's a this type of curve known as platykurtic. Platykurtic. When we increase the sample size and the data distribution in a bell shape, this is known as mesokurtic. Okay. And when we increase the sample size and data takes shape of this, so it is leptokurtic data. Leptokurtic. Okay. So how to find whether my data the normally distributed or not? Through value of skewness and kurtosis. If value between -1 to +1, it means data normally distributed. Ideally, the skewness and kurtosis value should be 0, but it is not possible. So when data skewness and kurtosis value outside -1 and outside +1, data not normal. So if your value like 0.126, it means data normal, there is no problem. If my skewness value -2.8, it is not normal. If kurtosis value -3.6, not normal. If my value 7.8 outside the +1, not normal. Okay. And the third most effective method, that is we report in our result, that is KS test. So generally we report the result of KS test in our research paper or thesis. So here p value should be greater than 0.05. It should be non-significant. So we should keep in mind, only for assumptions purpose, we need p value should be greater than 0.05. Okay. And the after the concept of normality, now I come to the concept of homogeneity. What do you mean by homogeneity? Homogeneity means the dispersion of the data or variability of the data in a particular category should be constant with the other category. What do you mean by this? Here now you can see it's a graph. Okay, so I'm taking 5 families. The graph is expenditure and income. Okay, so we know there is a positive correlation, higher income, higher expenditure. Okay, I took 5 families whose monthly income 50,000. 5 families. I'm taking 5 families, and their mean expenditure 30,000. 30,000. So one family expenditure may be 35,000, other family 32, 30, 28, 25. It's a range. What is the range? Maximum minus minimum. So range is 10,000. What is the range? Range 10,000, and the distribution of curve, you can see it's a normally distributed. I'm taking 5 families whose monthly income 1 lakh rupees and their monthly expenditure 75,000. 75,000 mean. So mean 75,000. One family, the expenditure 80,000, 78, 75, 72, and the 85 to 70. Sorry, 80 to 80 to 75. 80 to 70. Okay, so here the one family monthly expenditure 80,000 and minimum 70. So you can see here the graph to the distribution. And what is the range? Range is 10,000. 10,000. Now the third family I am taking, whose monthly, 5 families whose monthly income 1.5, 5 families, so total 15 families. So the expenditure is 1 lakh. One family monthly expenditure 1 lakh 5,000, 1 lakh 2,000, 1 lakh, and the last is 95, 95,000, 95,000 to 105. What is the range? Range again 10,000. So whether my data homogeneous or not, the range should be constant across the group. There are 3 groups. Range should be constant. If it means in each category, the variability of the data should be same. If variability of the data across the group same, it means my data normally, homogeneous. Now second case, same example I'm taking, the expenditure and expenditure and income. Okay, 5 families monthly income 50,000, 5 families monthly income 1 lakh, 5 families monthly income 1.5 lakh, 1.5 lakh. Okay, and there are the mean value same across the one is 3 group, the 30,000, 75,000, 75,000, and 1 lakh. Okay, so here the one family expenditure 50,000, other 40, 30, and the one family 20,000. So what is the range? 50 to 30. And the second group, the expenditure is 1 lakh, 90,000, 80,000, 75, and 60. So what is the range? The maximum is maximum 1 lakh, and minimum the 60,000. So range is 40,000. Here range is 30,000. And the 5 families of whose monthly income 1.5 lakh, their expenditure is 1 lakh. One family expenditure 1 lakh 10,000, 1 lakh 5,000, 1 lakh and 90,000. Here range 20,000. So this data heterogeneous. Why heterogeneous this data? Because range not constant across the group. Range different. Variability of the data different across the group. So this is a concept of the homogeneity. Now question is how to find the whether my data homogeneous or not through Levin test. If p value of the Levin test, we can say the data normally distributed, otherwise data homogeneous. ठीक है, अभी देखिए. Now there are 2 pictures. Now here the range uh, constant range, uh, more or less same across the categories. Jitni bhi categories hain, you can see here 5 7, but here range is very less, low variability, and in last case very high variability. So it is completely, so the data is not homogeneous. Okay, and now sometimes correcting the problem. So when we apply any parametric test, we check whether my data normal or not. We check whether my data homogeneous or not. Okay, sometimes what happens, my data normal but data not homogeneous, my data not normal but homogeneous, my data not normal not homogeneous. It means in all the three conditions we cannot use parametric test, we cannot apply parametric test, because the condition of parametric test, both the means your data should be normal and as well as homogeneous. Now question is, if my data not normal not homogeneous, then what should we do? So we will correct our data. So there are three methods of correcting the data. One is log transformation, square root transformation, and inverse or reciprocal transformation. If my data not normal not homogeneous, then what should we do? We go for non-parametric test. Okay, now you can see the log transformation. Before log transformation the data is skewed, but after the log transformation data more or less normal, not absolutely normal but more or less same as the square root transformation. The data positive is skewed, but here the data the more or less after correcting it is normal, same as the third method. You can see the data normal before the transformation not normal, and after the transformation normal. Now we come to the parametric test. So we will discuss here 5 tests: one sample t-test, independent t-test, pair t-test, analysis of variance, repeated measures of ANOVA. So first of all, we should understand in which condition we should apply one sample t-test, in which condition we should use independent t-test, in which condition we should use pair t-test, ANOVA, and repeated measures ANOVA. So the parametric test, I told you, it's the assumptions based test, and we should know the normality of the data. Now there are 5 parametric tests. One is one sample t-test, independent, paired, ANOVA, and repeated measures ANOVA. One by one I'll explain. The one sample t-test we use when we have the population and we take a small part of this population, and then we compare the sample mean with population mean, and we develop the hypothesis. There are 2 hypotheses: null hypothesis and alternate hypothesis. Null hypothesis means population mean equal to the sample mean. Okay, and the sample mean, and alternate hypothesis means sample mean does not equal to the population. If my data not normal, then what should I do? I will use non-parametric test, one sample Wilcoxon rank sign test. Okay, now you see the condition of the independent t-test. Independent, where should we use independent t-test? What are the applications of independent t-test? When we compare the two groups, y, that is dependent variable, and x means independent variable. So I am comparing two groups. Y metric data, one question should be metric, and independent variable should be non-metric, means male and female. Okay, I am developing the, or my simple hypothesis, it's a statement. I'm giving the statement, there is a gender discrimination in private sector, and I'm saying females are getting lower salary than male employee. It is my simple statement. Okay, so I will develop the hypothesis, null and alternate hypothesis. In null hypothesis, we always assume there is no significant difference between the two. It means both are getting equal cell. But alternate hypothesis says no, there is a significant difference between the two. And here we assume x1 bar does not equal to the x2 bar. Okay, so here we will say, again I am saying Ekta, I am saying in an independent t-test we compare two groups. I am saying there is a gender discrimination in society, or females are getting lower salary than male teachers. Okay, ये मेरा hypothesis. So I will develop two hypotheses. In null hypothesis, we always assume there is no significant. It means both male and female are getting same salary. There is no discrimination. But alternative hypothesis is no, there is a significant difference. How will I prove this? So you can ask me, sir, how will you prove? So I will say I will take, it's my population. In this population, I am taking sample of 20 male teachers, and I asked all the 20 teachers, what is your salary? Then after getting the salary, I will add all the male teacher salary, male, and 20 female. Okay, 20 female and 20 male. So मैंने first उससे पूछा what is your salary? One female teacher said 40,000, other said the 43,000, and so on. So I will take mean of this female teacher salary, and then I asked the salary of 20 teachers, male teachers, what is your salary? One said 55,000, other said 60,000, and so on. So in an independent t-test, we compare two means. We are comparing two means. We want to know the difference. So whether, and we should keep in mind, when we compare the two means, always we will get a different value. But whether this difference significant or not, p-value tell us. If p-value less than 0.05, it means there is a significant impact. If p-value greater than 0.05, it means there is no significant difference. Both are getting equal salary. So for testing the hypothesis, to checking the significant impact, our p-value should be less than 0.05. So same case study we can use, the control group and another experimental group. One is control group. When we compare the outcome of control group and the experiment group, okay, then we can use the independent t-test. If I want to compare the score of male and female participants, okay, for example, I am conducting one test. So my hypothesis is that female are better than the male participant. It is my simple hypothesis, because everywhere you can see the females are performing well in comparison to male, whether male are students और आप देखिए कि चाहे स्टूडेंट यूनिवर्सिटी में गोल्ड मेडल हैं, so everywhere female are getting more gold medal और उनका जो परसेंटेज ज्यादा है. So when we compare the two groups, we use independent sample t-test. I want to compare the result of one district or other district, so I can use independent t-test. So this is the जैसे मैं if I take the sample of your the some male participants in this FDP and some female, okay, so I want to know whether I conducted 100 marks question on research methodology. So how to check whether male are better or female? I will take mean marks of male students and mean marks of female students, and on the basis of difference. So I told you, when we compare the two groups, always we will get the different value. But whether this difference significant or not, to this p value tell us. Okay. Now the second, so the second is, sorry, the pair t-test. So first of all, I want to complete this, then I will take your queries. Where should we use pair t-test? Pair t-test when we observe 2 times, before and after. For example, before joining this faculty program, I conduct one test of the first participant score 71, and after 1 week faculty development program, I want to know whether his score improved or not in research methodology. So his score may be 77. Second participant score may be 57, 36, and 52. The condition of a paired t-test, respondent should be same. We observe 2 times same respondent to check the difference. Okay, so here we use paired t-test. You can take another example. If you want to reduce your weight, you joined gym to reduce your weight for 1 month, and before joining uh, the gym, your weight 75 and 82. Second person, third person weight 80. Okay, and after the gym join, your weight reduce 70 and 80 and 73. Okay, so when same respondent observed 2 times before treatment and after treatment, we use paired t-test. Like doctor give prescription to the patient, the end time period is 1 week. Okay, so before treatment, the he observed the fever, and after the treatment he observed the if difference is there, it means uh, the treatment is good. Okay, we can say treatment is. Now the independent t-test, what is limitation of independent t-test? We can compare only 2 groups, 2 categories, 2 levels. But if we want to compare more than 2 groups, 3 groups, okay, then we use analysis of variance. Analysis of variance, nothing but extension of independent t-test, because the limitation of independent t-test, we can compare only 2 groups, male, female, rural, urban, private, public. ठीक है ना? So we can, but if we want to compare more than 2 groups, whether the salary discrimination, the education on the basis of education background है या नहीं, जैसे कुछ participants science, commerce and arts. Okay, so we want to know that is it any discrimination on the basis of your education background? क्या ऐसा है कि science teachers are getting more salary than commerce and art, or commerce teachers are getting more salary than science and art, or arts teacher are getting more salary than science and commerce? So when we want to know the difference in mean more than 2 levels, we use analysis of variance. So the limitation of paired t-test, we can observe 2 times before and after. If we want to repeatedly, if we want to measure repeatedly same respondent, then we use repeated measures. And for example, in a 3 months training program, you join the one training program where you want to reduce your weight. So it's a baseline weight. So the first baseline weight, first participant weight is 95, and after 1 month weight reduce 90, after 2 months weight 85, 85, and after 3 months 80. Second participant score 93, after 1 month weight 85, after 2 months 80 and 78. Okay, so here we are measuring repeatedly same respondent. one time, two time, three time, four time. It means when we observe more than two times, we use repeated measures ANOVA. When we measure repeatedly same respondents, we use repeated measures ANOVA. So okay, so we understood the case study of the independent t-test, pair t-test, application of ANOVA, application of repeated measures ANOVA. Now, question is when your data, but before applying the independent t-test, I will check, because I told you every statistical tools and technique has its own assumptions. So whether your data normal or not, homogeneous or not, okay. For example, your data not normal, not homogeneous. Then what should we do? You will correct your data. Still my data not normal, not homogeneous. Then what should I do? I go for non-parametric test, which is equivalent to the independent t-test, and name of this test is Mann-Whitney U test. Mann-Whitney U test is not doing any new work. It is simple comparing two groups. But here in an independent t-test, we compare two means. But in a non-parametric, our continuous data, if we have continuous data, it will convert into ordinal and it will create the rank of the data. So here we will compare mean rank or mean rank. We will compare mean rank of the two groups. So Mann-Whitney is same as independent t-test. It is not doing any new work. It is, why am I using non-parametric Mann-Whitney test? Because my data not normal, not homogeneous. That is why I am using Mann-Whitney U test. The second is pair t-test. If data not normal, then what should we do? We go for Wilcoxon signed rank t-test. This test is not doing anything new. It is just measuring the impact of before and after. It is same as pair t-test. Equivalent of ANOVA, non-parametric test, that is Kruskal-Wallis test. Why am I using Kruskal-Wallis test? Because my data was not normal, not homogeneous. That is why I am using Kruskal-Wallis test. Kruskal-Wallis test is not doing anything new. It is same as comparing more than two rank. Okay, and the Friedman ANOVA, it is equivalent to repeated measures ANOVA. So I am taking a case study of one sample t-test, then the independent t-test, peer t-test, and the ANOVA and repeated measures ANOVA. हाँ, अभी कोई क्वेश्चन है तो चलिए मैं क्वेश्चन ले लेता हूँ. If you have any query, you can write in your chat box. Otherwise, I start hands on. Okay, I start. So the first is one sample t-test. Where should we use the one sample t-test? One sample t-test is used to test whether a population mean is significantly different from the hypothesized mean. One sample t-test. ANCOVA different from the ANOVA, but here we are not focusing the ANCOVA. ANCOVA basically, and the condition of ANCOVA y, that is outcome variable, and this outcome variable metric, and this is non-metric x1. There may be 3 or more categories, and other variable the metric. So it's a condition of ANCOVA. So ANCOVA, the purpose of ANCOVA to note, the purpose of ANCOVA, basically we use it's for the control purpose. We use the analysis of the ANCOVA. Okay, जैसे example ले लें ANCOVA का कि for a you want to measure the difference in shopping mall in your city. There are, you are taking you are taking three shopping mall, the M1, M2 and M3. Okay, but so you can say that M1 is better than the M2 and M3. So there may be many possibility that why M1 is better than the M2, M3. So there may be possibility that it is located within the city and it is easily, and the maximum people can visit easily to this shopping mall. So what will we do if we want to check in Encova, we want to check the impact of advertisement on sales. This is my sales. Okay, so here there are M1, M2, M3, three shopping mall. So I found the M1 better than the M2 and M3. But now we but we will take other variable also to whether it is correct or not. The other variable, this x1 and this x2, it is the continuous variable metric, and this one non-metric question, and this metric. Okay, now the if this metric means number of visitors, when the location of this M1 is good, so naturally number of visitors will be high. So we cannot say the advertisement influence the sales. The other factor also influence the sales. So you for more detail you can go through the book Andy Field book. Andy Field book. Here you can go through the concept of ANCOVA, factorial ANOVA, MANOVA, MANCOVA, factorial MANCOVA. There are many tests available in this book, so you can go through, because today our objective not to discuss the ANCOVA and other tests. We are focused only one sample t test. Okay, so one sample t test means we are comparing. It's a population mean. We are taking the hypothesized value, and we are comparing whether this population mean significantly from the other mean or not. Okay, p value means probability value. When we calculate the through SPSS, we obtain the probability value, p value. P value means 95%. Actually, in a social, the p value means probability value. Probability value, we take 95%. Check the level of significance, 90% and 99%. So generally in social science we take we check the significance level in a 5% level of significance. 5% means it's our normal distribution curve, 2.5 ml, 2.5 upper tail, 2.5 2.5%, and 2.5 this, and it is mean. So 5% means it is a two-tailed. 5% means when we take 100 sample from the population, like x1 bar, x2 bar, so the 95 sample, 95% sample will lie between the this range. It's a confidence interval. So 95% of sample mean will come in this range, and only 5% chance means 2.5% chance maybe the sample mean may outside this lower tail, and 2.5% outside this the upper tail also. So for more or scientific study you can take p value 1%. So but in social science we take p value 5%. Now the condition, the data continuous hona chahiye. Now the case study is this. It is a very simple case study. You can see ABC University indicates that the mean weight of obtained by students in a class 53 के, ये एक university ABC, and university saying in our university mean weight of a student 53 kg, but a teacher from the same university claimed that it was more than 53 kg. He is saying the weight is more than 53 53 kg. So I university said, prove it. How do you say the mean weight of a student more than 53 kg? So teacher randomly selected 10 students out of the 100. The first student weight 50, second student weight 55 kg, 54, and this. Okay. And now we will develop the hypothesis. What is our hypothesis? The hypothesis, null hypothesis, means population mean equal to sample mean. And alternate hypothesis says no, population mean does not equal to sample mean. If p value greater than 0.05, it means there is no difference. The mu and x same, there is no difference. But if p value less than 0.05, it means there is a difference. The sample mean not equal to the population. Now, question is how to check this. So I am taking the case study. One sample t-test, one sample t-test, yes, one sample t-test. Okay, now you can see this case study, one sample t-test. So first of all, we will write all the information in a sheet. Yes, Ekta, क्या question है बेटा बोलो? Ekta, yes, you can ask. क्या अनम्यूट करूं क्या तुमको? बोलो. चलो मैं अनम्यूट कर रहा हूं एकता तुमको. आप पूछो बेटा एकता. यस, व्हाट इज योर क्वेश्चन?
सर आपने बताया कि अगर p वैल्यू ग्रेटर देन 0.05 है, इट मींस देयर इज नो डिफरेंस बिटवीन द मीन एंड द पॉपुलेशन मीन एंड सैंपल मीन. तो सर p वैल्यू ग्रेटर देन होनी चाहिए या लेस देन होनी चाहिए?
हाँ, देखिए हम जब भी कोई भी हाइपोथेसिस डेवलप करते हैं ना, टू टाइप्स हाइपोथेसिस, वन इज नल हाइपोथेसिस एंड अदर इज अल्टरनेट हाइपोथेसिस. नल हाइपोथेसिस में हम ऑलवेज एज्यूम there is the population mean equal to sample mean. There is no difference. And here, how will decide whether population mean is equal to sample mean? This p value decide. If p value greater than this, it means the mean 53 kg and your sample also near to 55 kg. Okay, near to this 53 kg. It means both are same. Okay, but alternate hypothesis says if your sample mean, alternate hypothesis says your sample mean does not equal to the population mean. This is population mean and this is sample mean. So who will decide? This p value tell us the 0.0. If your p value less than 0.05, it means your difference is significant. If you want to know the impact of advertising expenses on sales, whether this advertising expenses significantly improve the sale or not, so you will test the hypothesis through simple regression analysis. And if your p value less than 0.05, then you can conclude, you can generalize. But in the null hypothesis, we assume there is no significant impact of advertising expenses on sales. Okay, now I ये देखिए, okay, now I am checking the assumption of this parametric test. So how to check it? So for checking the, go to analyze, then I am checking assumption, and then the descriptive. I am checking the normality of the one sample t-test. analyze, descriptive statistics, explore, and then weight of students, transfer into this, and the statistics, nothing to do here. Plots, yes, press this button. Normality plots with test. Okay, and then continue. After continue, okay, now you will get the output. So if p value greater than 0.05, it means your data normally distributed. Okay, just wait, result is coming. Yes, yeah, now you can see. Is it visible to you? Can you see this? Can you see this output? Yes. Okay. Okay. Now you can see the p value. How to find whether my data normally distributed or not. So you can see here the test of normality. Test of normality. And what is the p value? 0.20. Here p value greater than 0.05. What is your p value? 0.20. 0.20 means 20%. It is greater than 5%. Okay, it means your data normal. There is no problem. Now we test the hypothesis whether the claim was right or wrong. Now you take this case study. I am performing the one sample t-test. One sample t-test, analyze, compare means, and one sample t-test. Okay, analyze, compare means, one sample t-test, and then weight of students transfer into this variable, into test variable. And what is the t value? T value is 53 kg. It is population mean. Okay, and then you press this button, okay, and after okay you will get the output. So this is your output. I told you when we compare, always we will get different value, but whether this difference significant or not. For example, there are two groups. One group salary, male teacher salary 50,000, and female 40,000. Male salary 50,000, female salary 45, male salary 50,000. There are three conditions, and female salary 40. So when we compare the two groups, always we will get the different value. But whether this difference significant or not, who will tell us p value. So here there is a difference of 10,000. It is a big difference, significant difference, jada difference, and here difference is low. Now in this case you can say, well, there is no significant difference. It's a more or less same salary, but here you cannot say the same salary. So p value decide. Here in this hypothesis, the null hypothesis means mu equal to sample mean. And what was the mu? Mu value was 53 kg. And what is the value of the sample mean here? The teacher took 10 students, and this mean is 56.90. Again, it is a difference, but whether this difference significant or not, we will not decide. Who will decide? P value. If p, and the other alternate hypothesis, if p value If p value less than 0.05, then we will say this difference is significant. This difference is significant. If p value greater than, we will say there is no. It's a by chance. By chance, you selected 10 fatty student. Okay. So now in this table you can see the three columns: p, degree of freedom, and significance. This p significance means p value. This value tell us about the significance level, and this value greater than 0.05. What is the value? 0.191. It is 19.1%, greater than 5%. So we do not reject this null hypothesis. It means population mean equal to sample mean, and teacher claim was wrong. Now we will interpret it. Teacher claim was wrong. Now question is how to write this result. So the writing of this result, so we will write this way. We will report this result in our research paper. From the output, since p value greater than 0.05, we do not reject the null hypothesis that sample mean is equal to population mean. Okay, there is no difference. It was there is no difference, and it means teacher claim was wrong. Teacher was saying it is significantly different. It is not significant. It is very less difference. Now the second case study, independent t-test. The purpose of independent t-test, I told you, we compare two groups. This test is used when there are two mutually exclusive groups. Mutually exclusive group is male, female, public sector, private sector, rural, urban. When we compare two groups, then we use independent t-test. Here, what is the condition? One independent variable should two levels. Y equal to x. X means independent variable. IV independent variable. There may be two levels, and dependent variable should be continuous, and observation should be independent. It's a prerequisite of independent t-test. Now I am taking very simple case study to explain the concept of independent t-test. In this case study, the example to know whether the salary of male faculty members in private institutions is equal to salary of female faculty members. यहाँ टीचर जानना चाहता है, टीचर wants to know whether the salary of male teachers equal to salary of female teachers. Okay, so he collected data from the private institution, 20 male and 20 female teachers. Now we will develop the hypothesis. So our research design: dependent variable, metric; independent variable, non-metric, two categories. Metric means salary, it is dependent variable. Now we will develop the hypothesis. In a hypothesis, we assume, in a null hypothesis, there is no significant difference between getting salary by male and female faculty members in private sector. There is no difference. Both are getting equal salary. If p value 0.05, we will say there is no difference. But alternate hypothesis says no, there is a significant difference. The male teacher salary and female teachers, and p value would be less than 0.05. Okay, now we take the case study. The case study, one sample independent t-test. Independent t, yes. Now you can see the data set. In this data set, there are two category: one male male participants. Researchers selected 20 male teachers, and second column you can see the salary. The male teacher salary 45,000, second said 46, 40, 54, 57, and so on. And 20 female teachers he selected from the private institution, and he asked, what is your salary? The teacher said 38,000, second teacher said 29,000, and so on. So in a independent t-test, generally we are comparing two means. There are comparing two means, X male teachers mean and female teachers. So in an independent t-test, we are taking the mean of this group and mean of the family, female teachers. Okay. Now, as we know, it is a parametric test. I told you before using parametric test, we check the assumptions. And what are the assumptions? Data should be normally distributed, data should be homogeneous. How will I say my data normally distributed or not, or homogeneous or not? So I perform it, analyze, then descriptive statistics, and this explore. Now you transfer what is your gender into factor, and the salary of teachers in the salary of teachers dependent list, and press this button, plots, and then tick this normality plots with test. It will give us a result of KS test. And for homogeneity, leave-in test. Okay, you can see here leave-in test. So press this button, continue. After continue, okay, and then check the output. What are the output? This is my output. Now output. First of all, we will check whether data normally distributed or not from this table, test of normality. What is the p-value for male teachers? 0.20. What is the significance p-value for female teachers? 0.20. It means p-value greater than 0.05. 0.05. Data normal. There is no issue. Now we check whether my data homogeneous or not. Yes. Salary of teachers based on mean and live-in statistics. This is p-value 0.435, which is greater than 0.05. So I can say my data homogeneous. Both the assumptions made. So we can apply independent t-test to checking the comparing of two means. Okay, now we perform the independent t-test. Go to analyze, compare means, and independent sample t-test. Analyze, compare means, independent sample t-test. Okay, transfer your what is your gender into categorical, and press this button, define groups. So there are two groups, coding for male 1, coding for female 2. So I am writing here group 1 and group 2 2, and then continue. Salary of teachers transfer into this test variable, and then press this button, okay. So you will get the output. What is your output? I'm just showing you the output. In this output, so what is my null hypothesis? Null hypothesis, the mean equal to the male teacher salary equal to female teacher salary. What is the salary? 49,000. 49,900 mean salary of male teachers. and mean salary of female teachers 39,400. Yes. Or I told you, when we compare always we will get the different value. But whether this difference significant or not, who will tell us? P value. So an alternate hypothesis says the x bar does not equal to x2 bar. It is not same. It is significantly different. So from these three columns, this is our the p value 4.08, degree of freedom 38, and p value 0.00 less than 0.05. It means this difference, not a small difference, it's a significant difference. So we can say there is a gender discrimination in a society. Females are getting lower salary than the male faculty members. Now question is how to report this result in our research paper. How to report? So reporting the result, you can see here, result table not visible. Okay, चलिए मैं फिर से can you see this table? Is it visible? Okay, I explain again. Okay, no problem. I will again explain. No problem. Thank you. Now, in an independent t-test, so I told you the null hypothesis, the x1 bar equal to x2 bar means sample mean. What is the salary of this is 49,000 male teacher salary 49,900 and female teachers mean salary 39,400. So whether this difference significant or not, I told you p value tell us. So in a null hypothesis we assume this difference is same, it is not a significant difference, but alternate hypothesis says no, this difference is significant. So how will we decide? These three values you can see, p value 4.08, degree of freedom 38, and p value 0.00. It means p value less than 0.05. We accept this result. It means now we can say this difference is significant. Now question is how to report the results of this okay, how to report the results. Now question, reporting the result, you can see from the output the t value was 4.068, that the number of degree of freedom 38 and the significant, and it was significant at p less than 0.05. Now we will write the result, mean value of each group. And we can say male teachers obtain higher salary, mean value and standard error, and female teachers mean value and standard error. Now we can say this difference was significant and we will write this. Okay, so this is the way to present the reporting the result of the result of independent t-test. Now second condition, paired t-test. In this case study, we compare same respondent two times, before treatment and after treatment, before manipulation, after manipulation. Respondents are same. This is a big difference. Okay. So Ekta, you go through the book. I told you degree of freedom. It's basically tell us the if degree of freedom means if sample size is more, degree of freedom would be high. So degree of freedom related to accuracy. Okay. So for more detail, you can go through the book and define it. Now the before and after. So paired t-test. The paired sample t-test compare two means that are from same individual. The condition is same individual, same object or related unit. The two means can represent things like, and we measure pre-test and post-test result. The data should be continuous and observation should be pre-test and post-test. अब ये case study you can see this case. ABC University arranged a special faculty development program for one segment of its teacher. The university wants to measure the change in the attitude of its teacher after the faculty development program. University thinks we should change the attitude of the teacher by joining them to faculty development program. And it has used a well-structured questionnaire to measure the attitude, and the university selected 20 teachers before the faculty development program. Now the data is continuous. The before faculty development program, the score of the first teacher 25, and after joining the faculty development program, the attitude score is 38. The same as the 35, 40, 24, 40. So there is a difference. This is FDP, FDP. This is difference. Now, whether this difference 38 minus 25, 45 minus 35 significant or not, can we say, can we generalize faculty development program enhance the motivation or attitude of the teachers? If this difference significant, if p value less than 0.05, then we can generalize, yes, faculty development program improve the attitude of teachers. Okay, now it's a case study. So we will develop the, first of all, we will develop the hypothesis. In null hypothesis, we assume there is no significant impact of training program on teachers' attitude. You can arrange so many faculty development program, but teachers do not want to change their attitude. It is null hypothesis. There is no impact of the training program on change the attitude. Just say before and after the score is same, but alternate hypothesis says no. There is a significant impact of training of teachers' attitude. Attitude will be changed. The score of attitude before and after will be different, will change. Now question is how to check it. Okay, no, the Praveen, you can go through the book ND field, because here time is constraint. I cannot explain or find out the degree of freedom. So there are two books. One is Rebecca M. Warner. It's a very good book, Applied Statistics. So here very beautifully explained the concept of degree of freedom and p-value. So please go through that there, and you can get the insight. And after the lecture, you can consult me, because here I cannot discuss due to some limitations. I need to complete the topics. Is it okay, Praveen? Okay, okay. After this program, you can, I will share my mobile number to you, to all the participants. You can contact me after this faculty development program also. So we can take your individual problem there. Okay. Now the it's a hypothesis. The one sample paired t-test. Yes, this is paired t-test. Paired t-test. In a paired t-test, you can see there are the performance or attitude of the teachers before the faculty development program. After the faculty development program, the score of first teacher increased 22 to 35. Second teacher 26 to 36, 28 to 36. Now we will check the normality of the data. We will not check the normality before and after. We will check the normality of the difference of these. The difference of before and after value. So we will create the other column. Either you can write manually 35 minus 22, 13, 36 minus 26, 10, or you can use the software. So transform compute variable, I'm creating the new variable difference, sorry, difference and copy and paste in type and labels. You can type and label here and then continue. So after transfer and then transfer before, now you will get the okay. Now okay, you obtain the uh, new table, that is difference value. Now we will check the normality of this column, this variable. So how to check it? Analyze, descriptive statistics, and explore difference. Okay, go to analyze, then descriptive statistics, explore. So explore difference and plots. Press this button and normality plots with test, and then continue. After continue, okay. So you will get the output. I'm showing you the output. अब output आप देख पा रहे होंगे. So what is the value of KS test? Here value of KS test, what is the p value? The p value is 0.20. 0.20 means greater than 0.05. So data normal. Now we can check the impact of faculty development program on teachers' attitude. Now I am performing pair t test. अब इस कॉलम का कोई रिक्वायरमेंट नहीं डिफरेंस का, वी विल यूज ओनली बिफोर एंड आफ्टर. सो हाउ टू डू इट? सो गो टू एनालाइज, then compare means and paired sample t-test. Analyze, compare means paired sample t-test, and transfer both the variable before and after. We do not need this third variable difference. And then okay. And after okay, we obtain the output. This is our output, you can see. So here output, the before faculty development program mean score was 24.75, and after the faculty development program, yes, and after the faculty development program, the faculty development program 33.25. Okay, there is a different value. Before faculty development program, the score, the mean score of the attitude score was 25, and after the faculty development program, this. So whether this difference significant or not, who will tell us? This p value. Now you can see the last three columns. Here t value minus 7.963, 19, and p value less than 0.05. Now we can say there is a significant impact of training program on increasing the attitude of teachers. स्टैंडर्ड एरर कौन सा है? स्टैंडर्ड एरर की तो कोई मतलब ही नहीं है यहाँ पे. इंटरप्रिटेशन के लिए वी नीड ओनली टी टेस्ट एंड सिग्निफिकेंस पी वैल्यू. स्टैंडर्ड एरर का कॉन्सेप्ट डिफरेंट है. अब देखिए, अब इसमें ये आपका केस आ गया. नाउ क्वेश्चन इज हाउ टू रिपोर्ट द रिजल्ट्स. Reporting the result from the output, the t value was minus 7.963. The degree of freedom on which this was 19. बिकॉज 20 - 1 डिग्री ऑफ फ्रीडम डिफरेंट होगा अलग अलग स्टैटिस्टिकल टूल के लिए। रिग्रेशन के लिए अलग तरीके से निकलता है और टी टेस्ट के लिए अलग। नाउ द पी वैल्यू इट वाज सिग्निफिकेंट एट पी वैल्यू लेस देन 0.05 एंड द डिग्री ऑफ फ्रीडम। इसके बाद क्या करेंगे कि बिफोर ट्रेनिंग प्रोग्राम स्कोर इज दिस मीन स्कोर एंड दिस इज स्टैंडर्ड एरर, and after the faculty development program the mean score is 33 and standard error is this. We generally compare the two means, this mean and this mean, and this difference was significant. Okay, now we take the other case study, analysis of variance. Analysis of variance, there are two variables y and x. We are comparing several means. Okay, in this case study you can see the case study of analysis of variance. This test useful to analyze situation in which we want to compare more than two conditions. There are three conditions, and what are the variables? Variables should, one independent variable should be more than two levels, and dependent variable should be categorical, continuous, and observation should be independent. In this case study, it is a very simple case study, an experiment in which a major department store chain wanted to examine the effect of level in store promotion. The experimenter wants to know the impact of in store promotion on sale. It was in store promotion was varied at three levels. It means in this case study there are the experimenter selected 15 outlets, 15 department store, 5 selected, the 5 department store he is not giving discount, no promotion. 1 2 3 4 5 outlet, and 5 outlet he is selected, he is giving medium promotion. Medium means 10% discount in 5 retail outlets. Total 15 department store in a city. 1 2 3 4 and 5 choose, he is giving here high promotion or high discount, 30% discount. So he wants to know whether the sale of this group will be same for this group and this, or sale will be different. So we will develop the null hypothesis. In a null hypothesis, we assume the outcome, the mean, the null hypothesis. The null hypothesis says the null hypothesis says the H naught equal to x1 equal to x2 equal to x3. It means in all the three conditions the sale will be same, x1 bar, x2 bar and x3 bar. In whether you give discount 10%, 30%, it doesn't matter, sale will be same, we assume in a null hypothesis. But alternate hypothesis says no, there is a one pair of mean different from the other. The one pair, this pair may be the different from the this one pair, or this pair may be different from this pair, or this pair may be different from this pair. Okay, this is our alternate hypothesis. It means result will be different. Now we check it. The analysis of variance. So ANOVA, yes. ठीक है, ये देखिए अब ये डेटा सेट है, आप नॉर्मेलिटी चेक कर लीजिए, जैसे पहले किया हमने नॉर्मेलिटी और होमोजेनिटी, अब उसमें टाइम हम वेस्ट नहीं करना चाहते, वी जस्ट डायरेक्टली कंप्यूट दी ANOVA p value. Okay, so go to analyze, compare means, one-way ANOVA. Analyze, compare means one-way ANOVA. Okay. And then sales promotion, it is categorical variable transfer into factor, and sales, which is the sales, you can transfer here dependently. Okay. And then press this button contrast, nothing to do here, just continue, and press this button post hoc, press this button Bonferroni, and then continue, and then options, press this button descriptive, homogeneity of variance, and means plot, and then continue, and after continue, okay. ये आपका आ गया रिजल्ट. ओके, अब मैं इसको जरा समझा दूं रिजल्ट को. So there are three outlets, three types. One, there is no promotion, mean sale is 22 lakhs, and the second is where we are doing medium promotion 32 lakhs, and mean sale where we are giving high discount 50. So I told you in null hypothesis we assume all the mean value same, but from the data we can say it is not looking same, it is different. But null hypothesis says it is same, all the three value, but alternate hypothesis says no, this one completely different from the other pair, x2 bar or x3 bar. This is our hypothesis. So whether this difference significant or not, 22 lakhs, 32 lakhs, and 50 lakhs. So who will decide this? ANOVA table. And this ANOVA table, p value 0.025. 0.025 means 0.0, it is less than 0.05. So there is a significant impact of promotion. The no promotion, medium promotion, and the high promotion. But we do not know whether medium promotion significantly increase the sale or not, or high promotion increase sale significantly or not. We do not know. That is why we use post hoc analysis. In a post hoc analysis, we create two pair, no promotion with medium promotion, one pair no promotion with medium promotion, and we check the p value. And then second pair no promotion with high promotion, we check the p value. If it is not significant, we will conclude high promotion increase the sales. Now you can see the post hoc results. No promotion with medium promotion. What is the p value? 0.840. It means 22 the y and x, 22 and 32. This difference p value greater than 0.05. So this difference not significant. Now we compare the other group, 22 and 50. No promotion with high promotion. What is the p value? 0.025. So this difference is significant because p value 0.05. Now we will conclude that the high promotion increase the sales of the commodity. Now we can report our result. A one-way between subject ANOVA was conducted to compare the impact of promotion on levels of sales. There was a significant effect of amount of promotion on sales at point, because p value less than 0.05, and f in a bracket degree of freedom 2 and 12, and this is f value and p value 0. So we will report our result like this. Next case study of repeated measures ANOVA. You can see the repeated measures ANOVA. Yes. In this case study, the dietitian introduced new diet chart plan to reduce weight loss. The dietitian took 15 women who considered themselves to be in need of losing weight and put them on this diet for 3 months. Their weight was measured in kilograms at the start of the diet, and then after 1 month, after 2 months, and after 3 months. So we observed 4 times same respondent. That is why we will use the repeated measures. Now here, how to develop the hypothesis? We assume null hypothesis. There is no significant impact of diet on weight loss. कोई फर्क नहीं पड़ता diet plan का. But alternate hypothesis says no. There is a significant impact of diet plan on sales. ठीक है, ये मैं इसका वो बता देता हूँ. एक मिनट. डेटा सेट, रिपीटेड मेजर्स एनोवा. इसके बाद फिर मैं आपकी कुछ क्वेरी ले लूंगा. पैरामेट्रिक खत्म हो जाएगा हमारा, फिर मैं आपकी क्वेरी ले लूंगा इसमें. ठीक है, बस अभी 1 मिनट और वेट कर लीजिए, देन आई विल टेक योर क्वेरी. फिर उसके बाद आगे बढ़ेंगे. एक मिनट, जस्ट वेट 1 मिनट. अब रहने दें. Okay, so can you hear me? Now we can, so please inform me through chat box. Can you hear me? Yes, thank you, thank you, thank you. Okay, okay, okay. Now I perform the repeated measures and now you can see in this case study the baseline weight of 15 women. First women was 105, 102, 103 and so on. After 1 month, weight reduced 98 kg. After 2 months, weight reduced 92 kg. And after 3 months, the weight 75 kg. Now, same as for second respondent 102 and 73. 103 is 68. So through this data, we can say there is a a good training program, here the weight reduce significantly. But we will not decide p value after estimating the value, p value. We will decide whether this difference is significant or not. So how to check it? Go to analyze, general linear model and repeated measures. Here, general linear model and repeated measures. Here the factor is written, so you write here weight, GHT. How many level? 4. And press this button, add. Press this button, define. Select all 4 variables and transfer into within subject variable. Press this button, model, then continue, then contrast. Press this button, polynomial, select repeated, change, continue, then press this button, plots, nothing to do, post-hoc, nothing to do, and press this button, options. Transfer overall into display and transfer weight. वेट की स्पेलिंग थोड़ा गलत हो गई है, इसको मैं चाहूं तो चेक भी कर सकता हूं. चलिए मैं दोबारा से परफॉर्म कर रहा हूँ. दिस स्पेलिंग मिस्टेक, नाउ आई करेक्टेड. तो वेट एक रीसेट, WEIGHT वेट है ना, ये सही है स्पेलिंग. देन फॉर, ऐड, define, select all 4, transfer, and model, nothing to do here. Contrast, select polynomial, repeated, and change, and continue. After continue, options, transfer overall and weight, and tick, compare main effect and select SIDEC, SIDEC, and then press display, estimate effect size, transformation, and continue. Now we will get the output. I'm showing you the output. Yes. So before the faculty development, before the joining program, now you can see the weight is 102.8, and after 1 month mean weight 93 kg, after 2 months 85, and after 3 months 69. So it is a significantly decreasing. Whether the significant difference is not, this p value tell us. And the p value you can see here, all the p values, whether it is Pillai trace, Wilks lambda, Hotling trace, or Roy's largest, all the p values less than 0.05. So there is a significant impact of a training program to reduce the weight of the participants. ठीक है, ये हम इसको लिखेंगे. Now I come to the non-parametric test. Non-parametric tests are assumptions-free tests. We do not need to check the normality of the data or homogeneity of the data, because these tests are the assumptions-free tests. Okay, there is no need to check the normality and homogeneity of the data. In this case study, it's a case study. Now in this case study you can see the life of tire. So I am showing you the data set, the parametric non-parametric test. So today we will discuss Wilcox-Conn-Rank sign test, Mann-Whitney test, Wilcox-Conn-Rank, Kruskal-Wallis, and Friedman. So in this case study, you can see the company X Tires has launched a new brand of tires and claims that under normal circumstances, the average life of tires is 40,000 kilometers. Tire will run 40,000 kilometers. But retailer wants to test whether the company claiming right or wrong. So he selected 10 tires life First is 36,000, second is 37,000, three is 41,000, four is 41,000, and so on. Now the null hypothesis is the population median is equal to hypothesized median. Okay, so we perform it. The one sample Wilcoxon rank sign test. We do not need to check the normality of the data. I'm just directly performing the one sample t-test. Go to analyze, then non-parametric test, and one sample. Analyze, one sample t-test, non-parametric, one sample t-test. Press this button, test sequence for randomness. Then press this button, field, and transfer number of tires here. And then setting. Compare median to hypothesized median. What is the median? 40,000. He said tire will run 40,000 kilometers. And then run. After run, you can see the output. You can see the output. Yes, this is output. Okay. One sample Wilcoxon rank sign test. And what is the p value? The p value of this test is the p value. It is the p value 0.574. Okay, 0.74. It is less. Sorry, it is greater than 0.05. It is greater than 0.05. The hypothetical median was 40,000. Observed median 41,000. So this difference is not significant. This p value tell us. Okay. Now the second test, the Mann-Whitney U test for independent sample. For independent sample, we use Mann-Whitney U test. Mann-Whitney U test. In this case study, there are two groups. The doctor wants to know the impact of drugs. So there are two types. One is the drugs in the tablet form, and other is the syrup form. So doctor selected two groups. 10 patients. The one group is giving ecstasy tablet to the patient who are suffering from the depression level, and 10 people selected for syrup. So the doctor wants to know whether ecstasy tablet more powerful than syrup or not. So null hypothesis, we assume there is no both are equally correct. Okay. Now the observation of this group is this. So we will take median value of this group and median value of this. So how to perform the Mann-Whitney U test? You go to analyze, then non-parametric test, and here there are two methods. You can go through this legacy dialog also. Legacy dialog, two independent samples. So two independent types of drug into grouping variable. There are two groups, 1 and 2, and then continue. Transfer this variable into test variable, and by default you can see Mann-Whitney U test, and then OK, and after OK you will get the output. The output is this is output. In this output, the ecstasy tablet users mean score is 15.9, and those who are taking the syrup, the mean rank is 5.9. Now question is whether this mean significantly different or not. This asymptotically significant p value tell us, or here this difference 15 and 5, it is significant difference. This is significant, and the Mann-Whitney value is this. Now question is how to report the result of this test. So we will report the result of this test. You can see the Mann Whiteley test. Yes. The acoustic tablet user median value this were significantly more depressed than drink syrup median value this. So U value U equal to 4, Z equal to -3 and P value. Now the question is how to find the median value. So you can find the median value through descriptive statistics. ठीक है, कैसे descriptive statistics से find करना है ये देखिए. Go to this, analyze descriptive statistics, descriptive, and transfer the variables. Sorry, descriptive statistics. I need both the categories. Z value it is okay. I tell you. Z value it is same as t test value. ये देखिए पहले मैं इसका आपको descriptive statistics, types of variable, this and the statistics by default descriptive statistics and okay. तो ये देखिए रिजल्ट आ गया. Now from here you can take the mean value, median value. Sorry, the median value 33.5 and Parveen, your question, good question. Why median, not mean value? You are right. The answer of your question, why we are taking median value, because I told you the parametric test performed for metric data, and non-parametric perform for non-metric data. Non-parametric, we use non-parametric. Non-parametric means our data ordinal data. So when our data in ratio scale, so it convert into ordinal. It will create the rank of the data set, and then we will take the median, we will take median, because in a we cannot take the mean value for ranking data. We take only rank. Okay, देखिए कैसे. अब क्वेश्चन कैसे ये क्या है कि how to, now question is how to convert the rank. So in this case study you can see the rank. So we present all the score in ascending order like 3, 5, 6. It's a score given by the participants. So the lowest score treated as rank 1, then highest is 2. So we will take the rank. Okay. For manually, if you want to do, you can go through the book, ND field book. You can check it through manually also. So it's a concept of ranking. Then the third case study, Wilcoxon rank sign test means when we compare the two groups. We compare the two groups. Wilcoxon, yes. Yes, in this case study, you can see the 10 participants, they are feeling stress. So before taking the medicine, the stress score was 16, 15, 20, 15, and this. And after the taking the medicine, the score of stress 5, 6, 30, 8, 9. These are the scores. So we want to know the impact of medicine to reduce the weight. Okay. So this condition, same as PAT test, we are measuring 2 times before treatment and after treatment. So we will use here Wilcoxon rank sign test. Analyze, then non-parametric, legacy dialogues, 2 related samples. So transfer BDI1, BDI2, and by default you can see here Wilcoxon, and then okay, and after okay you will get the output. Your output is here. So this is output. So for your output, you can see the output, the mean rank of this is 5.28. Whether this difference significant or not, you can see this. P value Z value, it is just like t test value. Okay, so here the p value 0.047, it is less than 0.05. It means this difference is significant. The medicine is working to reduce the weight of the patient. Now the next is Kruskal-Wallis test. In a Kruskal-Wallis test, you can see the case study. So Kruskal-Wallis test, same as the Kruskal-Wallis test, same as the analysis of variance. ठीक है, अभी मैं डेटा सेट आपको शो कर रहा हूँ. ये देखिए डेटा सेट. नाउ यू कैन सी द डेटा सेट. सो डेटा सेट. ओके, थैंक यू प्रवीण. अगर आप देख सकते हैं तो बहुत अच्छी बात है. नाउ इन दिस केस स्टडी, द केस स्टडी इज वेरी सिंपल. द रिसर्चर wants to know whether coffee consumption increase heart rate score or not. Whether coffee consumption increase the heart rate score or not. So he selected 4 groups. One group, he is not giving coffee. 10 people. He selected 10 people and he is not giving coffee. No coffee. And other group, he selected 10 people. He is giving 1 cup coffee. And other third group, he is giving 2 cup coffee. And fourth group, he is giving 4 cup coffee. Now question is whether 1 cup coffee increase heart rate score significantly, or 2 cup increase significantly, or 4 cup. Okay, so it is, we are comparing more than 2 levels. So we will use Kruskal-Wallis test. Okay, now I am performing the Kruskal-Wallis test. Yes, analyze, then non-parametric independent samples, customized analysis, fields, and then heart rate score transfer into test, coffee consumption into groups, and setting, customized test. So we are using Kruskal-Wallis and all pair, and then run. After run, we will get the output. So I have explained the output. This is my output. So what is the p-value? 0.006. It means significant impact of coffee consumption. But we do not know whether 1 cup coffee significantly increasing the heart rate score, or 2 cup coffee increasing the heart rate significantly, or 4 cup. So we will do post hoc analysis. So just press this button. After pressing, you will see the output. Now you can see the output. So here the p-value, asymptotically p-value 0.006. There are 4 groups: no coffee, 1 cup coffee, 2 cup coffee. It's a box plot. And I'm pressing here independent sample t-test pairwise. When I do it pairwise, now I can compare the 4 pair. My test was dependent variable and X, 4 level. No cup coffee, with 1 cup coffee, with 2 cup coffee, with 4 cup coffee. So I will create 3 pair. No cup coffee with 1 cup coffee. Whether it is significant or not, we will check p-value. No cup coffee with 2 cup coffee, we will check this p-value result. And then third pair, no cup coffee with 4 cup. So first of all, no cup coffee with 1 cup. This no cup coffee, I'm comparing no cup coffee with 4 cup coffee. So what is the p-value? 0.528. it means there is no significant impact. You can take 1 cup coffee per day and your heart rate will not increase. Now, second, no cup coffee with 2 cup coffee. What is the p value? Greater than 0.05. It means there is no impact of 2 cup coffee to increase the heart rate score. Now I take the fourth pair, no cup coffee with, yes. The p value, it is less than 0.05. So you should not take more coffee, 4 cup coffee, you should not take. Otherwise, it will increase your heart rate score. Okay. Now the one case study, that is the paired ANOVA, Friedman ANOVA. Okay. Now Friedman ANOVA same as repeated measures ANOVA. In this case study, you can see some people wants to reduce their weight. Okay. So the initial weight is 63.5 kg. After joining the training program, 65.38. After 2 months, 81.34. Second participant score initially 62.98 and finally 69.31. So weight is increasing. Instead of decreasing, it is increasing. So from the data, I can say this training program not effective. But how will I decide? This p value decide. I will not decide. So how to perform it? Go to analyze, non-parametric test, legacy dialog, and K related samples. K related sample, selected all the three and transfer here. By default, you can see Friedman. And then OK. And after OK, you will get the output. The output is this output. Yes, this is output. So weight at start 1.9 range, after 1 month 2, and after 2 months 2.1. Whether this difference significant or not, who will tell us? This p value. And what is the p value? P value, it is 0.90. It is mean p value greater than 0.05. This training program not significant for reducing the weight. So this is about the paired. And the last case study I'm taking, that is chi-square test for the nominal data. Now in this case study, the case study of this sorry, okay, sorry, ये जो case study है, अब in this case study I'm performing. Now you can see the chi-square test. Chi-square test basically use when both the variable in categorical in nature. In this case study, the trainer wants to dance the cats. Okay, so the trainer, there are two variable, dependent variable and independent variable. So one is food, trainer giving food as a reward to the cats, and trainer is giving affection as a reward to the cats, and he's saying please dance. So there are two options. In front of cat, she dance or do not dance. So both are categorical. So when he is giving food as a reward, the cat is dancing. And the some cases you can say the cat is not dancing. And when he is giving affection, the cats are dancing. Yes, but some are not dancing. He took 150 cats. Some cats he giving food as a reward, some cats he giving affection as a reward. Now I am performing. I want to see the impact of food or reward. Analyze, descriptive statistics, cross tab, types of training, did dance, and press this button. Exact, nothing to do. Statistics, choose chi-square, tick this button, continue, then cells, expected frequencies, row percentage, continue, and then OK. Now I am interpreting the result. The result is this. Yes. Now you can see the result. So in this case study, we selected 150 cats. Out of the 150 cats, 30 cats, the trainer given food to 30 cats. Out of the 30, 20 danced and 10 did not dance. It means 67.7% dance and 33.3% did not dance. When he is giving affection as a reward to the 120 cats, the only 37.5% are dancing and 62.5% not dancing. It means from the data you can see the food for animal working more than the affection. But whether this difference significant or not, this chi-square test tell us 8.33 and significant value less than 0.05. It is 0.04. So it is less than 0.05. So we can generalize for animals food as a reward more important than the ये क्या कहते हैं आपका affection. ठीक. So this is about the अमित एक्सपेक्टेड काउंट जो होते हैं ना दो तरीके के, ऑब्जर्व काउंट एंड एक्सपेक्टेड. ऑब्जर्व काउंट वो होते हैं जो हम एक्चुअल लेते हैं, और फिर एक्सपेक्टेड की इतना हो सकता है एक्चुअली, अब वो है या नहीं है वो डिफरेंस से हमें पता चलता है. यस, एनी क्वेश्चन?